All right, so and just to make sure, how many of you guys were here last workshop? Raise your hand. Okay, if this is your first time here, raise your hand. Okay. All right, all right, all right. So for the people that are here for the first time, did you guys get a chance to install the VMware and ROS yet? Raise your hand if you did. Okay, raise your hand if you didn't. Okay, okay. So for the three of you guys, do you already know how to do it? Do you have the steps already or no?
Yeah, I looked at the instructions.
Okay.
I can do it, but there's just like.
Oh, yeah. So, I mean, feel free to kind of like, there will be like a few presentation slides. So if you can do it, as I'm doing it, I mean, it'll take a while, but go ahead.
I was trying to.
Uh-huh.
But whenever I try to open the like virtual machine, the version open.
Let me see, what year, do you know what year is your laptop by any chance?
It's pretty new, I think. I just got it last year.
And what Windows version is it running?
This is 11, I think.
Yeah, it should be fine. Try uninstalling it and reinstalling it again and see. And you're saying like just VMware, not like Ubuntu, right?
No, well, VMware, when I make the virtual machine and I try to
Run it, it gives you an error.
yeah.
So make sure that you're using the right version of Ubuntu. Make sure that it's for the right architecture. For you, it would be a x86. So make sure you're not using like a M chip architecture or something like that. So yeah, any other issues that you guys are facing or something? So everyone else pretty much have VMware and ROS, and no issue is kind of like stopping you from moving forward. Okay. And how many of you had a chance to go through the manual to kind of like get familiar with ROS by any chance? Raise your hand if you did. Okay. Raise your hand if you didn't. All right. All right, that's fine. So for what I'll be doing, you should be able to just kind of like copy and paste the commands and all that. And later you can go through them to better understand them. So I guess let's move forward a little bit. All right, so this is the board members for AI Research. AI Research itself is the RSO that is organizing this competition and some of the main workshops. I'm here, Israel. We have Vedant. He is currently not here. Humberto is also not here. Vedant is our vice president. Humberto is our treasurer. You know what? For the people that are here, they can kind of like present themselves and tell us a little bit about yourself and major and fun fact if you want. So, Sam.
Hey guys, I'm Samuel Lee. I'm the treasurer. I'm a freshman electrical engineering major. And fun fact about myself is that fun fact, I like basketball.
Oh, okay.
Hi guys, my name's Hector, and I'm the marketing coordinator. I'm a computer science major, and yeah, if you guys want to join the committee, please, you're welcome to. Free boost on your resume.
And I'll send an announcement.
My name is James Williams, and I'm the events and outreach coordinator, and I major in computer science. And the fun fact is I also like basketball.
Okay. So as you can see from that question mark over here, we are in the process of, we're looking for a sponsorship coordinator to help us reach out to industry and, so we can get funding so we can actually, provide you guys with everything that you need. I didn't lie the first time. We do have things to provide with you guys, just like, we need more because the more money we can get, the more we can give to you guys. So if we can get someone who could try to like stay on top of that. Currently it's us doing it. And yeah, so next slide pretty much has an application link to. Oh, okay, yeah. So feel free to scan this. This application link will allow you to kind of like just apply if you want to be the sponsorship coordinator, or if you just want to be part of a committee. So a committee is pretty much, it's not like a specific, like a role where you have a lot of responsibility. It's more like, hey, I want to help out with this type of things, right? And I don't really want to, you're not signing a contract anyway, but you don't want to like, be like, how do I say? You just want to help out, but not really take on too much responsibility. So that's what the committee is for. So currently we have 3 committees, I believe. We have PR and marketing, which is led by Hector. So basically all you guys will be doing is help out with promoting the workshops, promoting the competition, and being responsible for our website as well in a way. So, feel free to like apply if you want to help out. The other one is the sponsorship and industry liaison committee. So this is to pretty much help out, trying to figure out what company can we reach out for to try to get some funding, to fund the competition, the workshops as well. And we have the workshop committee to just help out with these workshops. So yeah, definitely kind of like apply, and we'll kind of like move forward from there. All right, does anyone have any questions by any chance? Nice. All right, so we can start with this workshop. I will quickly go over like a few things, and then we will start in a way with the hands-on activity. So a quick recap of what autonomous driving is. With autonomous driving, you have 3 major groups. You have perception, which is trying to like figure out what is around you, and where you are, and all of that. And after that, you have planning. Is once you have that information, through your sensors, which will pretty much give you those information where you are, what's around you. The planning step is, what do I want to do with that information? Given that you have all of these going on, what's the next step? What are you supposed to do? And control is how you actually do it. The control interface with the actual physical part of the vehicle to steer the steering motor, the servo motor, and also the actual speed of the vehicle, which is the regular motor for it. So like I said last workshop, how can we easily or kind of like cheaply test your autonomous system stacks? You can use like a small scale platform like this one. This is an open source platform. You're free to modify it and fine tune it to your need. And it is a scaled model of an actual AV, autonomous vehicle. Most autonomous vehicles, is pretty much like this, built like this. As you can see from this right there, this is the chassis of a Tesla Model S, and this is the chassis of a Traxxas of one of the, vehicle like these. So as you can see, it's pretty similar, and this is another comparison. So you would have the chassis, all of the things that you would need in a car, and then you would have the sensors suite. So just like right there, they would have all of those sensors. You can have all of the sensors that you need. You can have LiDAR, radar, camera, and all that. So this is easier way to test autonomous systems overall, and we went over the major way to build this. You would start with the chassis design. You would next do system integration with camera, LiDAR, or whatever you need. You would have the VEST controller, which is the microcontroller integrated with a electronic speed controller to control your servo motor and also your motor, and you'll have your software architecture on top that is running on the computer. It is running your perception and planning and control algorithm. And all of that allow you to, either if you want to go straight to the industry, work for a company that does AV or do research. And for our purpose, you have all of those component perception, planning, and control. How you easily interface all of that is through robot operating system, which is the most commonly used framework for robotics. And we had an introduction to Ross last workshop. If you haven't had a chance to go over them, you can do that later. So with Ross, there's a bunch of libraries, a bunch of plug-and-play utilities that allow you to write things with perception, planning, and control, and even like interface the sensors themselves. So, sure, we have autonomous driving, but why do we care about racing, right? So, it's not like we are expecting cars in the future to just kind of like hey, I want to go to work, let's see who can get there fastest, that's probably not going to be ideal. But, with that being the case, why do we try to race? So the reason is because it allows you to easily test your autonomous system stack at the edge cases, right? So as you will see, as you will be developing your things, it's like a lot of things run fine when it's slow, but once you start speeding things up, things break. So that's why we try to emphasize or push toward autonomous racing, so that you can easily test your things, whether you are trying to get into autonomous systems overall, go to the industry, or do research. So that's why we have that. And of course, before we can actually test things on the physical vehicle, it's better to have a simulation to test things first, before we do anything, so we don't break things. For example, these small vehicles, even though they're pretty small, they're pretty cheap compared to an actual autonomous vehicle stack. If you were to buy one to test things out, it would definitely be in the 100K, because you guys went to we're at the lab, you saw the little small vehicle that we had, that was over 100K. Yeah, just it's like a 2-person vehicle, just because it's not, the reason you see autonomous vehicles now can be cheaper than this is because those are mass produced. So compared to research vehicles, those are not mass produced. It's yeah, so because those are not mass produced, so it can be pretty expensive. So when you compare, a few 100K to 3K, that's nothing. So that's why people are first testing things with small scale stuff, and and then they'll move later to bigger scale stuff. And before they even test it on small scale stuff, they will be using they try to use a simulator or something. All right. Let me see. Okay, so the simulator that we will use, I'll quickly go over it real quick so that you understand how it works, just in case you want to tweak it, because that simulator is not it's a in progress simulator. It was literally made by another person who was just interested in doing it. So Robo Racer or F110 fits 1/10 scale of an actual race car, which is this open platform right there. And the simulator that we use is based on a really simple 2-dimensional gym simulator, and it integrates with ROS. Things that you can do with it is that you have a vehicle dynamic model, so it's trying to models the vehicle, try to make sure that try to make the physics work the same way as it would on an actual vehicle. And it has collision detection algorithm, although it's not perfect. it tweaks a little bit, as you will see later. Like once you hit a wall, it might make the vehicle like spin around and dance. So it's just not the intended purpose, but it's not, it doesn't work too well. So don't get your hopes high, by the simulation, all of that. So it does interface with something called a gymnasium. If you're interested in machine learning, you can easily, to that simulation, like train a model to do something. We will not go over that for this semester at least, but just letting you guys know, just in case that's something you're interested in. Core concept of like a gymnasium, we can just quickly go over that. And core library that it depends on, it's NumPy, Pillow to like load the maps and a few other things as well. And F110 GymROS is a bridge library that just connect the Python base to ROS, so you can easily like test things using ROS. So just like I mentioned before with ROS, the main things are about nodes. You have nodes and they communicate to topics named buses in a way. So a node can subscribe to a topic or publish to a topic. So that's how they communicate around, and all of the nodes together will make the entire system. So it's the same base for that. And another thing that you should probably know is that for our vehicle, the steering is based on something called Ackermann steering. And with Ackermann steering is that it's pretty simple. The two variable that we'll use is pretty much speed and angle of the steering wheel, and that angle will be kind of like this. So just keep that in mind. And you can have negative angle if you want to make it go left or right, all of that. So yeah, so there's that. Let's kind of like go over that simulation and how to like install it real quick. All right. Does anyone have any questions so far? All right, so if there's no question, make sure you go to AI Racer, the workshop webpage, and go on the live canvas link. And you should be able to see this. Let me know if you kind of like get there, or if you need help getting there. So just tiny URL AIRacer.workshops. Yep. Huh? Oh, so once you're on that webpage, just for this workshop, this is the workshop that we're doing. These would be the prerequisite, which you should already have done for the most part. And then the live canvas is this, where the code that I will kind of like go through, they'll be there, so you can easily copy and paste them instead of like trying to like type them, as I'm doing it. I will pretty much put the guide there as well. Let me know if you need any help so far, and feel free to start launching your VMware and simulation. All right, so if you refresh it, you should see new guide. So this is the guide to installing the simulation. What I'll do is instead of just me just sitting there and do it and you do it, because I mean there's really no point. Uh, I will let you guys go over it. I mean it's pretty straightforward, and I'll walk around and answer question and kind of like help people who are stuck so that people don't get behind. But just follow this. You should be able to install it. And if you run into some errors, let me know. And of course, if you have already installed the simulation, or if what you're doing is kind of like working, help out others who are kind of like stuck, so we can, help each other out. And I would say make sure that you kind of like have it on your laptop as well, so you can quickly see, because everyone is not going to be at the same pace for this. So. Yep. Are you copying the link? I mean, it should be there. Like, it's right there. Like, just click on this. This is way easier. Yeah, so it's this website, or yeah. Wait, raise your hand if you cannot get there. Okay, so everyone has been there, and okay, we're good. Okay. This page that I'm showing right now. Okay. And raise your hand if you cannot get here, if you're stuck or something. So everyone got it. All right, bet. Did you have a question? Yeah. For the what? Oh, you want me to go back? Yes. So it's not just the live canvas, it's just the actual document. It should be right here, Intro to Rust 2 Workshop Manual. So instead of it on that other website, it's on the main page now. So you can quickly just go over the past workshop stuff. I've added a few things as well, but yeah. All the way down. For this practice exercise? No, so this is a random reading. So it's like you are fabricating a no, for this exercise, no, it's just yeah, because this is not homework, obviously. It's just something that if you feel like, hey, I'm a nerd, which I am too. There's nothing wrong with that. I'm a nerd. I want to like practice things, so try to do that. It's a pretty good like
I just thought like
yeah.
you wanted us to do like an actual Ross
No, I didn't kind of like that would be a bit like I didn't really show how to do that, so there's no point. So with this, basically you should be able to do that practice thing, given you went through all of these. But obviously you don't have to do it. It's not like a requirement to move forward. Yeah.
I'm glad you put it right there.
Yeah. What's good? I mean, I can come as well if you want me to. Okay, that's fine. Where'd you get set?
So, here, how do I find my home directory?
So to find your home directory, you can easily go into terminal, right?
I open.
Like a new tab, right? And type pwd. So like you can just copy that and move forward. Let me just add this as a note real quick. And there.
Thank you.
No problem. Oh yeah, it was already there. Let me see. So the question that he asked is, once you get to that spot, how do you change this to your actual home directory? You can easily find your home directory by going to another terminal tab and just type this command, and you should be able to kind of like, do it. Yep.
So, specifically the slides that you showed, simulation,
Uh huh.
is it R-based?
Yeah. Always.
Isn't that one that you're not totally reading the other simulation?
So I mean, you would need Arvis is just what's showing the simulation. So the actual simulation is done through the other part. Arvis is just to show it.
Okay.
Yeah.
So,
So the simulation is fabricating a fake sensor data because the simulation is not actually connected to a vehicle. But if you are in the simulation and you run a command to figure out like what is the laser is seeing, it will say that, oh, I'm seeing this right there, but that's not actually there. It's just the simulation is fabricating that data.
oh, and that's only done through the other apps that you showed.
Yeah. Yeah.
Okay.
Um. Let's see. Yep. Oh, you have a problem or?
Since I really couldn't find this symbol.
Let me come back real quick. So just a side note, if you just got here, you can go to this website and follow the instructions to we're working on installing the simulation, which are here. But yeah, go on that website. You should. need help? Always stuck?
Yeah, 'cause it's like 30 minutes. Okay, now you're at home. What? Yeah, so just pick up where you left off. Keep it slow. But wait, what?
You don't, oh, to actually lunch it? Yeah, so, are you trying to source it first? Did you source it? Sourcing is like, you guys already figured this? First was to source.
Yeah. Well, I might be licensed.
You know how to like change the try to see if it's there. It's also in the,
I guess you're like
manual
here,
scripting,
but
so like,
I know, yeah, it's a little bit. And
What?
then, I think if you just launch it again.
Because,
Yeah.
Didn't you say final name?
but that's the next step, so.
you just go home.
No, we're not for the.
It's, it's in there, go down.
It's the one below.
What did you trust in my channel?
Yeah.
Yeah.
Oh, okay. Yeah, nice.
Oh, I think
Yes,
it's.
sir, it's right there. Okay,
How's it looking? Thumbs up if you're kind of like done. Okay, just fine. All right. Hold up.
Yeah, bro, thank you.
I'm trying to set it up right now.
Yeah.
What?
Oh, wait, no, it worked.
Oh, it worked?
Yeah, it worked. It just 60
I'll leave
seconds.
it.
I forgot.
What is the Apple account to?
Do you have, do you have, yeah,
Well,
have you installed the mouse? It gives you step by step how to install the mouse. You go to the home. And then if you go to premium, you should see install mouse. You done it? Are you done? No, that's either way.
Not that far.
Would you tell me you did?
Hmm?
You said, would you tell me you didn't do here?
So you see how like this needs to be a full home address.
Mm-hmm.
So did you add that or not?
I think so, yeah.
Like what was it before? Was it just, what did
Yeah.
you do? What did you do?
I don't know, I just copy and pasted like these and then like it showed me the
And that map, did you just copy that?
Yeah.
whole thing? No, so you don't copy it. So what you do is says replace the home thing, which was the home Israel, with your actual home directory. So over here, the way to find your home directory, you can open a new tab and just see whatever you do. And you see it says home Samuel. So just put a home Samuel before sim workshop. Yeah.
Okay.
And it should work. That's right. Yeah. So I'll try to like post everything that we collected, either like tonight or tomorrow morning. Yeah. Just like everything is on that website that I showed you. Just follow through. Yeah. Sure. Alright. Is anyone stuck? Just making sure. All right. So who already got it done? Raise your hand. I'm just trying to see. 1, 2, 3. Nice. Okay. So if you already have it done, right? Have you tried running the teleop node, so kind of like to control the vehicle with your keyboard? Did you guys try that? Okay. And try like switching the map because this map should also be there. So, just go in the configuration file and just change it to this one. It just so you need to make sure you where did you launch the you need to have a header file. Where did you have that file? You want to do that? So you need to run these and make sure you sort everything as well. Yeah, that's fine. Yeah. Okay, so once you yeah, and note that once you like change the file, you have to build it again, unless you're using the similar option. Alright. Okay, so we do have another part after this for the automatic emergency braking. Let me see. Who is done with having the simulation working fine? Raise your hand. 1, 2, 3. Okay, I need probably a bit more than that. Let me see. Who else is having issue right now? You having issue?
No, I had issues with sending the VMware. I thought I had everything downloaded, but I realized that I was missing something, so I just downloaded it. It's still being.
Oh, yeah.
I just need the map, just notify the, seems like you know.
Oh. So modify the configuration file. That is, yeah. And then look at what map is there and just change that one. Let's do it. Yeah, that's how that control you have to press the stop. Yes, so to reset the position, use a T roll. Right. So if you are playing around with the map or like with the simulation, and you know like something is happening and the car is lost, you can use 2D pause estimate to just do this, and the car will kind of like respawn there. Let me see. What can I do? Did you have a question? Are you good? It works? It's good. Anyone just got it working? Raise your hand real quick if you have it working. 1, 2, 3, 4. Who is still trying to get it to work? Like you're not like doing something else, but trying to get it to work. Raise your hand. 1, 2, 3. Okay. Yep. Inside of your workspace. Yes. Did you have a question? Oh, never mind. Whoa. You need to source Ross. Do you remember how to source Ross and stuff? Every new terminal you open is gonna do that. So now I do copy here. Okay, so when did you install Ross? So long ago?
Today.
Today?
Yeah.
Okay, so did you skip a part to install the
I had trouble with it.
development thing?
I don't know. I had trouble with it, so I like deleted it and then restarted it all over, and then it was fine. But the thing I should probably restart it again.
No, you're probably just missing a report. Did it touch fine?
Yeah.
Did you do that? After you do this, try to see if it works now. If it doesn't, continue from there. All right, any questions? Anyone stuck somewhere? All right, so, oh, question?
So you just, copy it? No,
Okay, if you're tired of like using copy build, then you can do it once and then add the option simulate install. Go straight to that whenever you modify the file, it just automatically so
you work on?
Okay, so raise your hand if you are, let's say, almost done with getting the simulation ready. Okay, just one. All right, so all right, we can go to the next part. So for this one, we will probably not be able to finish everything, but because oh, my computer is slow. Jeez. Too many things open. All right, so let's go to the next topic, which is it's loading a little bit. Oh, that's a lot. All right, automatic emergency braking, which is also known as AEB. And so what is automatic emergency braking? I'm sure everyone here, I've used a vehicle, and most vehicle nowadays, even some of the old ones, they do have some form of AEB system where, you could be driving and you are about to collide with a car in front of you, and it's just kind of like hit, and you don't hit the car, but the system kicks in and it brakes for you. So that's what AEB system is, automatic emergency braking. It is also known as ADAS, Advanced Driver Assistance System. Well, in other words, it's more ADAS, Advanced Driver Assistance System, has a AEB system in it as well. So how it works is that it is continuously monitoring the road, and it try to like figure out, oh, is this a threat? And if it's about to collide, then first thing it usually does, it warns you by like a beeping or something like that. And if you don't react in time, it automatically presses the brakes for you. And it has been proven that this system reduced crash by a lot, and also reduces the severity of the crashes themselves. So I believe in Europe right now, all new cars that are being manufactured must have that system in there. And today we will pretty much trying to go over the basics of that system. Later toward, later toward the slides, there'll be a few math things around. So don't worry about that. It's more about just so if you want to get deep into it. But yeah, so for the perception module, you have your sensors, which are your LiDAR, radar, and camera, and your decision module processes those data to do something with it. In our case, all it does, it's always monitoring the environment to decide whether it needs to brake or not. And with the LiDARs themselves, we can, in a way, try like understand how they work. And understanding how they work will allow us to, in a way, have a better understanding of AEB systems in general. So with LiDARs, how do they work is that they send out like this LiDAR right there, the one with the orange tip. Basically, all it does is it sends out light pulses. It has a transceiver that sends out the pulses and a receiver. So what happens is that once it sends out a pulse and that pulse comes back, the LiDAR, the LiDAR unit calculate how long it took that light pulse to come back. And let's say with that, you are able to know how far away whatever that thing that LiDAR had reflected on is. So to give you an example of like how that math is pretty much simple, it's let's say you have something that's moving 10 meters per second, right? And it takes 2 seconds to get somewhere. So with that being the case, like how far away would you say that thing is? It's pretty simple. Anyone has an answer? If it's going 10 meters per second and it takes 2 seconds to get there, how far away is that thing? Anyone? Okay. Yeah. 20 meters is that simple. So basically, something is moving at 10 meters per second, right? And it gets to the destination 2 seconds. I just want to make sure it's clear, right? Okay. I just want to make sure we're on the same page. So yeah, so it just means that that thing is 20 meters away. So now, if it's like going there and come back, and it takes 4 seconds. So how far away it is? So basically, it's moving 10 meters per second, right? And let's say there's no slowdown, no nothing, it's just immediate movement at 10 meters per second. And once it gets there, it comes back, right? And you're only able to track like, okay, when you send it out and when it comes back, and you see that, hey, it took 4 seconds for it to go there and come back. So how far would you say that thing is? The speed is 10 meters per second, and it took 4 seconds to go there and come back. Yeah, still 20 meters. And the reason is because it took 2 seconds to get there and 2 seconds to come back. So that's how you found out like how far that thing actually is. So it's the same principle with the LiDAR. Basically, the light wave or the light pulses, it moves because it's light. It moves at the speed of light. So, and the speed of light. I mean, they already know the speed of light. It's 3 times to 10 to the 8. So they use that speed and use that same formula. It's like the speed of the thing that's moving, how long that it took, and you divide that by 2 to get the distance to that actual obstacle. So using that simple formula and how long it took for a light range to come back, you'd be like, oh, there's something over there at this amount of there's something over there at this amount of distance. And what the LiDAR does is that it does a sweep of a scan in a way. So it start right here, like send light pulses, and then moves a certain amount of degree, send it again, send a bunch of them. It does that a lot, in this case, it does a whole sweep 40 times a second. So that's why this LiDAR is that expensive, is because it's that fast. So it does the whole sweep 40 times a second. And with all of those, a bunch of light pulses that comes back, it's able to give you like a bunch of points. And with those points, you can kind of guess like, oh, there's like a bunch of things over here. So those are like obstacles. So that's what LiDAR is doing pretty much. So, and of course, these are like things about like, how to, regarding range and accuracy. LiDAR is one of the most accurate sensor when it comes to like finding the distance of something. However, it's not perfect, obviously. It all depends on like a bunch of other things, how far away it is, because after a certain distance, a specific LiDAR won't work because it's made for like a certain distance, and usually the higher the energy of the pulse, the further away it can get. And if you are using a LiDAR and there's like let's say something that is reflective, like like a mirror or something that's like shiny, it might mess up the LiDAR reading a little bit. So that's something to keep in mind. Another thing is, the air can be cloudy, all of that. Although LiDAR is still very resistant to cloudy air, it might still mess it up a little bit. It's just something to keep in mind. And now let's talk about, time to collision. So which is pretty much like the the basis of automatic emergency braking. So time to collision is pretty much trying to figure out how long it will take for a vehicle to hit something, given that it is going at that speed. So just like the example before, if your vehicle is going at 10 miles per hour, or let's use the second example, if it's going like I don't know, like 10 meters per second, and there's a car in front of it, that car is like stationary or something, it's not moving, and you're trying to figure out how long it will take you for you to actually hit that vehicle. You can just use that same like formula that we use, and then it will tell you like, oh, if it's like 20 meters away, then it will take 10 seconds. And the whole idea behind AEB system is that it continuously scan and see what object will I be hitting in like the least amount of time. And there's a threshold where if I'm about to hit something in less than, let's say, 2 seconds, then it applies the brake. So it's a pretty simple concept, and that's kind of like the whole idea behind it. So if I'm about to hit something, just apply the brake. Now, I mean, there is some geometry involved. You can go through these a bit later. Basically, this is the formula for it if you wanted that. And the way it works is the top part, which is pretty much like how far away you are from the object. And the second part is how close you're getting from the object. So basically, it's distance to object divided by relative closing time. So the reason it's saying relative is because if two cars are moving, you would still need to find out like how long it would take you to collide given your given velocity. But it's a different scenario if one car is moving and the other one is not. All of that. That's why it's saying like it's relative. So this is like an example. If a car is 50 meters away and the ego vehicle is kind of like your own vehicle, if that vehicle is going at 16.7 meters per second, if you do the division, you'll see that TTC is 3 seconds. So that means like you will end up hitting that vehicle in 3 seconds. And if in your algorithm, if the threshold is like 3 seconds, then it will hit the brake. If it's 2 seconds, it won't hit the brake, and once it gets to 2 seconds, it will hit the brake. So that's the whole idea behind it. This is that same formula, but with mathematical expression to take into account like the maximum of like the object that's closest to you. And there's a bit of trigonometry involved. Is basically it's like, let's say you're not going straight at the vehicle, you're going at an angle. To be able to find the number that matters, you need to use that formula. And it works even if you're going straight or if you're going at an angle. So it makes our life easier. And this is going over the formula again and typical threshold. So you'll be like the first stage where probably kind of like warn the driver, and then the second stage is that it partially slow down the vehicle, and the last stage is kind of like full braking. And this is typical ones are 2.5 to 3 seconds. That's warning. Brake intervention is 1.5 to 2, and then emergency braking would be like less than 1.5 seconds. So a bunch of things can affect it, such as the vehicle speed, how slippery is the road, all of that. And we'll be using a LiDAR for it, for our situation, and like to this is the basics of how the LiDAR itself works. Once you connect it and you're trying to read the LiDAR data, which is published on scan, you should get these numbers. So to give you an example, if you are running the simulation, you can open the terminal and browse to topic list to see the topics that are being published, and scan right there is one, and you can use browse to topic echo scan, and use this once so that it just outputs it one time instead of like continuously outputting it. And these are the reading that the LiDAR is giving us from that simulation, of course. So it's saying that the minimum angle of the LiDAR is -2. It's in radian, by the way, and the max is 2. It increments the angles, the steps at which it does the scanning is 0.004, and the maximum range of the simulated LiDAR is 30 meters, and those are what it's seeing right now. It's saying that over here in that area, there's something that's like 1.32, 1.35, 34, 33, 33, all of that. And as you can see, as you are getting toward here, the distance is like smaller because like this is smaller than here. And as you move past it, the distance should kind of like get further as well. So like once you get in front, and then comes here and it gets smaller again. So yeah, so that's pretty much what it's doing. And let me see, let me go back here. So in our next step, we will pretty much try to like implement that with the laser scan. A bit of warning, it can seems a bit intimidating, especially if you're not used to programming, but you can definitely like later take a look at the code and try to like understand exactly what it does. And let me see. So this would be the code for it. Let me just add it real quick. Oh, and also, if you want to leave a feedback, feel free to do so, so we can improve these workshops overall. So, if you go on the live canvas and refresh, you should see the parts about automatic emergency braking. So this one, it is a bit lengthy, but it goes over how you whoa. There we go. It goes over things step by step, explain how the formula works and why we're using cosine and all that. And it gives you like an example of a calculation. It gives you like how the laser scan message works. And this is like a step-by-step guide to how to create the AEB system or like node for it. Go through it, you create a package, you create a configuration file, you add these file, and then make sure that these are in there. This is the setup Python file. Make sure that this is in there. And you can simply, copy and paste these. So you test it to see that it works, and you implement the ITTC. So that code pretty much does exactly what I was describing earlier on how to actually implement it. And once you're done with the code, the reason it's that long is because there's a lot of like explanation in there. And you can create a param file or a lunch file if you want. But once you have this part, you can simply just run it and try to move the vehicle and see, and if it's like testing, if it's working basically. And you have some advanced feature that you can try on if you want to, up to you. Summary of what we went over, and then there's like a practice section for if you want to expand on your skills. The whole idea is, let me see if I can find it real quick. So you can feel free to start working on it here if you want, or later at home or something. I don't remember where I put it. Was it plus 2 x? Oh, okay. Okay. Hold up. Let me just show. Oh, you gotta go right now, or? Okay. Okay, that's fine. Let me see. What do you want to talk about it right now, or? I mean, sure, we can. Or next week if you want. Yeah, we can do it on Discord as well. That's fine. No, I mean it's up to you. Like, you said you have to go in 5. Okay, so okay, I guess we can talk about it a little bit. So, do you know what it is overall or no?
I read about it, like Cavalry, I read like one of them, like really like a skill.
Okay.
I was like, you are in part of the lab, right?
Yeah. And you're undergrad, I'm assuming, right?
Yeah.
Mechanical or computer science? Okay. Your computer science. What's your classification? Junior or?
Like this is my 6th semester, so
Okay,
next year I'll graduate experience.
Okay. So if you are a junior, and have you worked on anything like that before or no?
On ROS, this is like my first time. I've experienced, I've done computer vision with Python, I've done tensor and Python programming for models.
Okay.
But like the ROS, this is the first time.
Okay. So, if you were to like join CAFL, the only thing you will probably be able to do is probably work on this project. And since you're like an undergrad and you don't have like extensive experience on working on this, what you would be doing for the most part is learning how to actually, learning those.
What do you
Which
think
is-
with this one? This is the test card that they use for the
For that project, yeah. So for our research group, what we do is we test like autonomous. We kind of like implement or research about like um, autonomous navigation algorithm, and this is one of our test cars. And before you can actually be able to like help, you kind of like need to like know how to use ROS and these things. So what we do.
I was getting like into it right now, and
Okay.
I think we like question about it, like watching videos about it.
Yes.
Obviously, it's not gonna be like an expertise, such a big expertise, but I can get used to it.
Yeah. So what I was trying to say is that yeah, you can definitely join, but what the most thing you would be doing right now would be learning. So that's all I'm saying. So it's like
I would like to.
yeah, that's fine. So I'm just like letting you right now. So you will probably spend like a good amount of time pretty much like learning about these, and then you'll have like tasks later. And if that's fine with you, then we can kind of like continue later, and have that discussion. Like on what part would you be interested in like learning more about and all that. But first and foremost, you will be pretty much doing like the workshops that we're doing right now. So this workshop is to also like help people um, be better because we actually do have people who are in the research group that are in this workshop just so they can kind of like learn. So yeah, that's kind of like where to start in a way. Unless if you already had experience, then they could like probably place you in an actual like research project already. But since this is like the first time using it, it's just get the hangs of it, and I'll probably message you later and probably like invite you to like our next group meeting and like we can talk more about it.
And the next meeting will be like next
It's
week.
probably be like Monday. We meet every Mondays at 12 actually. So.
12 in the Archer House building. Do you have that? Or?
So right now it's on Teams.
Okay.
Yeah, so it's fine. But yeah, it's nothing like it's nothing like a very it will be up to you because it's like how involved you want to get you want to be, and like as you start doing the things you will get more responsibility and all that. The thing with research is that research is not like a regular project. For a regular project we have clear steps on like what to do and all that. Like with research everything is pretty fluid, and how active you get is up to you. So like do you have like like the drive to like explore something, basically, and trial and error, because no one will be able to like guide you. You see how I'm like doing this workshop? I'm only like I didn't know this beforehand. Like like I'm actually like learning on my own, and it was through that. So it's like I learned it. It wasn't like a clear guide. I was like experiment. I'm just creating this guide to help people learn faster. Because it took way longer to learn it, but yeah. So it'll be pretty much that for the most part, and you can like experiment and stuff.
Okay, so it's something that like I really would be interested in. So it would be okay like if I send you like a message on Sunday, so
Yeah, you
so
remind me. Yeah, sure.
I can like see the meeting, so I can see like how the meetings usually go, like what I can like contribute.
Yeah, of course, yeah, we can definitely do that. I should be reaching out to you before then, but if I don't, message me again.
Oh,
Yeah, I'll get to you.
perfect.
Alright.
So I can like say like.
No, that's fine. That's fine. Cause we're pretty much in a way done. It's just like if you want to work on it right here, you can. If you don't want to, you can
I'll
work
try
out.
to follow the steps and like you had that or like try like if I have like any problems myself, try like to.
If you have any issue, message us on the Discord. Like like use the general chat or something. Like this is kind of like some people is probably having the same issue as well. Ask the question and we'll try to figure it out.
Yeah, by the way, like say
Xavier?
yeah.
Alright, nice to meet you. Uh-huh.
My question was first, assimilation. It's 2 arrows.
Oh, you didn't get it. So this one seems
That's
like.
what I thought you meant like one assimilation.
Oh yeah.
So I was just trying to get clear. So
Yeah, so it's not done yet.
otherwise it was 0 honestly.
No. So it should look something like this. Once you're done, you shouldn't be an error. And the map will be different, obviously, but it's what I'm assuming you just installed it, right? You just started. So did you do that part? Do that and build it again and see if it works.
So I run into not here, but
build it?
We'll just build it.
Yeah.
And then I just do like a build one.
Yeah, yeah. So let me see real quick. Um, Yep. Uh-huh. Say that again? Oh, just make sure like everything matches and the things you would need to add usually you start with this like it. But if you want to make sure that you got everything, you see I have edit plans to what you need to add this part and this part and this part. Maybe one thing to oh, you seem like a big top the G one. So two page? One page two? Nothing at all? Okay. Did anyone have issue with VMware on Windows where they couldn't copy and paste? I know there's like something about Vega. Anyone remember how to do that? I think what the issue is facing is that the clipboard is not shared between the folks. Yeah. Did you put the replacement?
Yeah.
When you were installing VMware, did you install the storage? Well, No, 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 not into that file. So, did you create that file or not? So, create that file. Create that file and copy this plus that. Oh, everything else, yeah. Oh, okay, yeah, so yeah, this is in that file. And you have Windows, it's what? Have you used VS Code before? You can install VS Code here. What would you like to do for Matthew? For coding? Yeah. Yeah, probably. Did you go into the email settings? I mean, it depends on what you need. Oh, to understand the loss itself? Did you go to the, like, the entire menu? Yeah, the workshop link? So, I guess, what can help is, one is practice and other resources is, look for online. There's a bunch of them, you know. Look online. So here's what's going to be oh, you gotta like go read it back there. You can go back to the yeah. Yeah, that's pretty much what you do. Yeah, definitely do that. Yeah, so you guys working, and do you have any feedback for the workshop or something? Anything you want to do? So give us feedback form. You know, any feedback is helpful. As you can see how I changed the workshop layout from last one so that this one is a bit more interactive. You know, instead of just you just following along everything that I'm doing. So I just give you everything already. But if you haven't signed in, sign in right now. If you have already, oh, okay. Yep.
You mentioned that research group?
Yeah. So there is a research group. Um, wait, you haven't heard about it? You saying?
No.
Okay. So, what's your major?
Mm-mm.
And classification again? Sophomore, junior.
Honestly, that's kind of a question mark right now.
Okay. How? When do you graduate?
What, sophomore?
Okay. So if you're a sophomore, currently for the research group, there's like a few options, right? So if you have the skills already, and you can be helpful for the research group, then Dr. Fellow will put you in a project that he has, and AI research is one of the projects.
What was his name?
Dr. Fala, it's the Capital Lab. So AI research is one of the projects. This project is the one that I'm doing, but there's like other projects as well. But if you don't have the skills yet, you're kind of like new to research, you will probably be with me in a way, and the whole most of the things you'll be doing for right now will involve learning about learning the technical skills to like be able to be helpful later in the future, and the technical skills, the way you learn it is pretty much through things like these workshops. So if you are interested, uh, shoot me a message on Discord, and then I'll send you the link to apply.
Oh, he here's the thing.
Uh,
It's other research thing.
which
Cause I was
was
invited. I guess FSI.
FSI. I mean, it's up to you. It's not like it's nothing pressing in a way.
No, if it's like more hands-on, whereas this is more software. I'm like, they both kind of work hand in hand, and you're like, I'll be learning X, Y, Z, and I'll be learning how to do other kind of E related stuff.
Okay.
over
Yeah,
there.
yeah. If you're interested, definitely, and if you are already doing these workshops, it's pretty much almost the same amount of work. Because if you weren't participating in this workshop, what you would be doing, if you just join, would be learning. So it's so so yeah. So if you think about it, if you're interested, shoot me a message. I'll send you the link to apply. We usually meet every Mondays at 12 to discuss like small tasks, deliverables, and yeah.
I thought there would be like some sort of limit as to how many we're gonna do these programs.
Well, so yes, there is, but because right now, if it was like it's not funded, so it's like it's like if it was funded, then obviously yeah, but right now it's not funded. Sure, you can get paid if you actually are like being helpful and working on a project, but if you don't have the skills yet, um, this is just to help you get into research and like actual research. Because most of the other labs, if you try to like join, you know, there's like a lengthy application. Well, there's a application process where you need to actually qualify. Because I mean, they would most of the time they would pay you, so that's kind of like work. We kind of do that here too. It's just that we are starting this program to help undergrad get into research by like teaching them the necessary skills first. So it's more of a undergraduate co-op thing, research co-op thing. So you just kind of learn. I mean, it's still fluid, as in like everything is not like defined yet. But if you are interested, then feel free to like apply. Yep. Oh man, I really don't never learn from. Because most people. Yeah, that is. Oh, you can copy what you do? No, so I just yeah, like you can. I don't know. I don't know if I can. Let me see. Let me try to send you the link. I guess you can look at it later and kind of like, yeah, but you can definitely like open it. Yeah, yeah. Alright. So, I'm gonna make this work. I actually prepared it. I mean, I had those documents ready, like, without being like, so I just grabbed them and did it, but I did plan on myself, making And of course, thank you for coming to this workshop. See you guys next week at the same time.